Hello everyone, welcome to my network lab. In this lab, we are going to see how VXLAN works using Arista switches. VXLAN stands for Virtual Extensible Local Area Network. It is a network virtualization technology that is used to create virtualized layer 2 network over layer 3 networks. In this example, we have two data centers, that is home data center and away data center. These data centers are located several hundred kilometers away from one another. We will configure the VXLAN to extend the layer 2 network from one data center to the other data center over the layer 3 network. We will use BGP to perform the layer 3 routing and forwarding. We will also configure MLAG in the leaf switches for high availability. We can design VXLAN architecture without using MLAG. However, VXLAN with MLAG is a more reliable design. As you can see, in our example, we are using leaf and spine design because leaf and spine design is well suited for VXLAN deployments. However, VXLAN can be deployed without a leaf and spine design depending on network size, traffic patterns, and other requirements. Spine switches are the core of the network that provides high-speed forwarding of traffic between different parts of the network. Leaf switches are located in the access layer of the network that is close to the servers and storage systems. They usually have large number of ports for connecting directly to the end devices. Leaf switches are connected to every spine switches in the network to form a reliable mesh topology. Let us start with the layer 3 configuration. In our case, it is BGP. As you can see, we have 4 autonomous systems in our design: 65001, 65002, 65101 and 65102. Now let us start assigning the respective IPs in the respective interfaces in the respective switches and disable the layer 2 functionality from these interfaces using no switchport command. Home data center, switch spine 1. So I have just assigned the IPs. Now let's do it for the other switch. Spine 2. Now leaf 1. Leaf 2. Let us do the same for away data center. Spine 1. Spine 2. Leaf 1. leaf 2, next we will do the BGP configuration. Let's start with the home data center. We will enable the IP routing and add the BGP neighbors in every switches. So starting from spine 1 home, so we have enabled the IP routing. The BGP autonomous system for this switch is 65001, which is mentioned here. The neighbor, one of the neighbor is 10.1.1.2, which is the leaf 1 home, and it has the autonomous system 65101. The other neighbor is 10.1.2.2, which is the leaf 2, and it is in the autonomous system 65101. And the other neighbor is 10.1.4.2, which is the spine 2, which is in the self autonomous system, which is in the same autonomous system. So this is the command for that. And the command redistribute connected is to send the traffic that is coming from the different autonomous systems. So next let's do the same for the spine 2. Leaf 1, leaf 2, so we have done the BGP configuration for the home data center. Let's see the IP route. As you can see, the leaf 2 is connected to different networks. The BGP configuration for the away data center, starting with spine 1 away, spine 2 away, leaf 1 away, leaf 2 away, so the last BGP configuration is between home data center and the away data center, is to make the link between both the data centers. This configuration must be done on the spine level, so let's do it at spine 1 home. Is still in the same autonomous system, but now we are saying that we have a neighbor that is 10.1.3.2, which is the spine 1 of the away data center. So let's do it for the spine 2 of the home data center. Here spine 2 of the home data center is connected to the spine 2 of the away data center, which is 20.1.3.1. Now spine 1 of the away data center is connected to 10.1.3.1, which is the spine 1 of the home data center. Let's do it for spine 2 of the away data center. Spine 2 of the away data center is connected to 20.1.3.2, which is 1.3.2, which is spine 2 of the home data center. So that concludes all our BGP configuration, which means that all these switches should see all the networks in our design. So let's check show IP route. As you can see, all the networks from our design will be listed in this. So now let's start configuring the MLAG for the leaf switches before we start configuring our VXLAN. MLAG stands for multi-chassis link aggregation. It is used to improve the network reliability with redundant connection. That is, a single server is connected to both the switches, both the MLAG switches. For example, in our case, a single server will be connected to leaf 1 home and leaf 2 home. So when one switch goes down for some reasons, we will still have the server accessible and we have enough time to fix the broken switch. In our design, we don't have actual use of the MLAG, but I'm configuring it for the best practice. Configure the MLAG peers. We will use a VLAN interface to assign the IP addresses to link the MLAG pair, and we will use a port channel to carry the MLAG traffic. So let's start configuring in the leaf 1 home. I'll push the command. So we are using the VLAN 4094 for MLAG, and in this interface we are assigning the IP address 1.1.1.1 as shown in our design, and we will use the port channel 1000 to carry the MLAG traffic, and we will enable this port channel 1000 in the interface 3, which is connected from leaf 1 to leaf 2. So in the MLAG configuration we have a domain ID, so this domain ID should be same for the other MLAG pair, so to make the synchronization. And here we have the peer address is 1.1.1.2, which is the leaf 2, and the local interface is 4094, which is 1.1.1.1. So we can check the MLAG status now. Show MLAG. So if you see this MLAG status, it says that it's inactive and it's still connecting because the configuration on the other side is not done yet. So let's do it on the leaf 2 home. So here let me push the config. So now the configuration is pushed, and here the peer address is 1.1.1.1 and the local interface is 1.1.1.2. So now let's see the MLAG status. Show MLAG, and you see that is active and connected, and the peer address is 1.1.1.1. and here on the leaf 1 we can check the status again. You can also see the message that it's connected. So show MLAG, it's active now, so it's connected, and the peer is 1.1.1.2. So the MLAG configuration for the home leaf switches is done. Let's do the MLAG configuration for the away data center leaf switches. Leaf 1 away, and next leaf 2 away, so the config is pushed for the MLAG. Let's see the MLAG status. You can see that the connection is started and the peer is connected. So let's see, show MLAG is active, and on the other side show MLAG is active too. So the MLAG for both the data centers are done, and now let's start the VXLAN config. Let me push the config of VXLAN. VXLAN config are only done in the leaf switches where it is layer 2. So let's start it in leaf 1 home. So here I have added an interface IP for the interface loopback 1. So I've just used this autonomous number, systems number as the IP, which is 65.1.0.1. so this is like the used for the VTUP, which is VXLAN tunnel endpoint, and I have added the two VLANs, VLAN 10 and VLAN 20, for our different VLANs in our data centers, and this is the basic command for Ethernet 4 from VLAN from leaf 1, which is connected to a server which is in VLAN 10, and Ethernet 5, which is connected to a server in VLAN 20. And now this is the VXLAN configuration, interface VXLAN, and the source interface is loopback 1. So loopback 1 is set with the IP 65.1.0.1, and the VXLAN VLAN 10 is set for VNI 1000. VNI is VXLAN network identifier, and VLAN 20 is set to VNI 2000 as shown in the drawing. And VXLAN flood VTUP. VXLAN flood VTUP is VXLAN tunnel endpoint, the endpoint that is gets the flood from the different VXLANs. So here we are receiving the traffic from 65.1.0.2, which is from the away data center. This can be added, like we can add more IPs in this command. For example, if there are like many pairs of leaf switches from the same data center or from the different data center, we can keep adding the IPs in this command, so it receives the traffic from these VTUP points. So in summary, VTUPs are endpoints in a VXLAN overlay network responsible for encapsulating and decapsulating Ethernet frames in and out of VXLAN packets, while VNIs are identifiers used uniquely for identifying virtual networks within the VXLAN overlay. So the command for leaf 1 is done. So now we will push the command for leaf 2 home. So the command is pushed. Here we are using the same IP for both the leaf switches in home data center because these switches are in MLAG, so it will consider that it's the same source. So for example, if this switch goes down, for leaf 2 of home switch goes down, then all the traffic will be sent through leaf 1. So for this reason we will have the same IP, or we can also use a secondary IP under the loopback interface 1. So that's the configuration for VXLAN Now let's do the configuration for the away switches. So leave one away, push the config. Here the loopback IP address is 65.1.0.2 and the VTAP endpoint is 65.1.0.1. so it means that it receives the traffic from this VTAP and also from these VLANs with this VXLAN network identifier numbers. So let's push it for the lift 2 away. So all the commands for the switches are pushed. So now we should able to send our layer 2 traffic over the layer 3 network, and we will receive it back here in the other data center. So now let's configure the IP for the servers to make the test. So I'm gonna set the IP 10.10.10.1 for the server 2 of VLAN 10, IP 10.10.10.2, server 1 of VLAN 20, IP 20.20.20.1, server 2 of VLAN 20, IP 20.20.20.2, server 3 of VLAN 20, IP 20.20.20.3, server 4 of VLAN 20, IP 20.20.20.4, server 3 of VLAN 10, IP 10.10.10.3, and finally server 4 of VLAN 10, IP 10.10.10.4. So now we gave the IP for all our servers. So now let's try to ping. For example, let's take server 2 of VLAN 10, which is here. Let's try to reach server 3 of VLAN 10. So ping 10.10.10.3. As you can see, we can ping it, and let's check the traffic while we are trying to ping it. So I assume that the traffic is coming via Ethernet 1. So let's capture the packet Ethernet 1. So now let us try to ping it back from server 2. So as you can see, we have some traffic. So if we check the traffic, we can see the VXLAN, which is using the virtual network identifier 1000, and it is using the UDP port 4789, which is the default port for VXLAN. If you can see in our config, I would have mentioned the port number 4789. So that's how the VXLAN works. Now let us check if we can ping the VLAN 20 between both the data centers. So let's try to ping from server 3 to server 1. Yeah, let's ping the server 1 of VLAN 20. As you can see, we can reach the other side from away data center to the home data center. And let us tree the traffic in Ethernet 5 of the leaf 1. Let me ping it again. So here it's in the leaf switch, which means it's only layer 2 and you don't see any information about the VXLAN. That is how a virtualized layer 2 network is created over a layer 3 infrastructure using VXLAN. Thanks for watching my video.